We're going to start by discussing the components of the building shell, a little terminology, and some history. The building shell includes the walls between the house and the outside air, the walls that are between the house and the garage, and those walls that are located between the house and the attic. The envelope includes the foundation walls between a conditioned basement and ambient air or ground, or between the basement and other unconditioned spaces, such as a ventilated crawl space. The ceiling plane is part of the envelope that's located between the house and the attic, or between the house and outside for a vaulted ceiling. At the floor level, the building shell includes cantilever floors that are hanging out over outside air, or those floors that are over a ventilated or open crawl space, or over an unconditioned basement or garage. The lowest portion of the building envelope is normally either these frame floors or a slab that can be on grade or at the floor of a conditioned basement, or even a slab at the floor of a conditioned crawl space. Understanding where this barrier between conditioned and unconditioned space is located allows you to focus your air sealing and insulation recommendations where they're going to save the most energy and give the biggest bang for the buck. Before we get into discussing our building shell or envelope in great detail, let's make sure we're all on the same page when it comes to specific terms. I have been in many meetings with various trades in multiple regions across the country, and I've learned that the same term can mean totally different things to different people around the table. For example, to a HERS rater, a knee wall is the wall that's between conditioned space and an attic space. But to a builder in South Dakota, a knee wall is a short frame down wall that sits above a concrete foundation wall. I like to make sure I understand the definition of a term that's being used. It definitely makes conversation easier. So taking a look at this drawing, the truss is the framing that provides support for the roof. It's the triangle that you're seeing here. Truss is the term for the entire structure that sits in the attic and provides support for the roof and the roofing material. The top of the truss, the part that supports the roof decking, is called a rafter. The ceiling joist is at the base of the truss that sits on the top of the wall. This is what you walk on when you're in the attic. At least you do if you want to stay in the attic and not step through the drywall and land in the room below. The drywall ceiling below is attached to the ceiling joist. The band joist is a cover plate around the edge of the floor joists between two above-grade floors. In the HERS rater world, we use the term band joist to be the cover plate around the floor joist between the first and second floor, or between the second and third floor, but the one at the very bottom of the house, between the foundation wall and the lowest level floor, is what we term the rim joist. That's the cover plate around the edge of the lowest above-grade floor. Now, these two terms, band joist and rim joist, are used differently by different trades and different people. Some say that the band joist is the cover plate that follows the lengthwise wood, and the rim joist is the cover plate around the edge of the floor that has the squares, the cover over the ends of the floor joists. But to be consistent with most HERS raters, the rim joist is the cover plate around the entire floor joist area of the lowest floor at the top of the foundation, and the band joist is the cover plate around the edge between any above-grade floors. Roof decking is the underlayment under the roofing. It's nailed to the truss rafters under the tar paper and under the roofing. Studs are the wall framing components. They're the wood that make up the walls. Floor joists are framing that provides support for the floor. The floor joists will be under the floor decking and above the ceiling of the level below. Sheathing is the underlayment under the siding of the house. It's going to be OSB board or some other type of underlayment that provides structural integrity for the walls of the house. The sill plate is at the very bottom of the wood components of the house. It sits directly on top of the foundation wall. There's usually some type of EPDM rubber or some sort of capillary break under the sill plate on top of the concrete, and the sill plate sits on top of that at the base of the lowest wall. The consideration of heat energy in our residential dwellings is nothing new. These are cliff dwellings in New Mexico built by ancient Native Americans. They were oriented to the south to allow for natural passive solar heating. Before the Industrial Revolution, wood fires provided light, heat, and a cooking source for our buildings. In the early 1880s, Thomas Edison invented the incandescent light bulb and built the world's first power station to provide electricity for his invention. By 1908, 8% of American homes had access to that electricity. Just 2 decades later, in 1925, 53% of homes were connected to the electric grid. By the 1930s, natural gas began competing with wood and coal to be the residential heating fuel of choice. Then we started to cool our homes with electricity. Evaporative cooling appeared in the 1920s, and window air conditioners in the 1940s. Since our gas furnaces gave us ductwork through which to move air, we started borrowing the furnace fan and the ducts for cooling, and central air conditioning took over in the 1950s. In a quest for comfort, we would stuff our walls with newspaper or horsehair, or, if you could afford it, the expensive luxury of actual mineral wool insulation. However, in the 1960s, insulation became a requirement in new home construction, and fiberglass bats were developed as an inexpensive and effective means to meet that requirement. Americans' hunger for electric consumption grew as we placed televisions, stereos, computers, and other electronics in our homes. Now we're recreating our electric consuming items in an effort to curb the rising costs that go along with rising energy consumption. Construction techniques themselves have changed as well. Homes built before 1940 were built with a balloon framing technique. The wall finish was generally lath and plaster. The floor joists sat on ribbon boards. The siding, sheathing, and roofing allowed air to pass through, and the walls were generally open to the basement and the attic. These materials were used on purpose, to allow the air to pass through the building, and to allow for convective looping, which would bring cool air up from the basement and provide some natural cooling and fresh air within the house. Of course, the open walls and floor cavities also allowed any type of fire to instantly engulf the house in flames and made for very uncomfortable drafts in cold months. After 1940, we started to build using solid sheet goods and platform framing. This helped block the air from moving into and around the house, gave us wall cavities we could insulate, and by making the floors each a full platform instead of sitting the floor joists on a ribbon, we have built-in fire stops on every level. So now you've had a history lesson and a terminology lesson. You understand how important it is to make sure that when we're discussing terms, we all know exactly what those terms mean. And you can see how we've moved through history, making our homes more energy efficient and safer.